Okay, 8th graders, today we're talking about using inequalities to describe real life statements. So first we have to decide what an inequality is. And an inequality is a mathematical sentence that contains all of the symbols that you see here below. So the symbols that you see here are less than, greater than, less than or equal to, and greater than or equal to. Some other key phrases that you may want to know that are associated with each one. Less than could also be referred to as fewer than. Greater than could also be considered more than. Less than or equal to might be is at most, or is no more than. And greater than or equal to is at least, or is no less than. Now, we also need to talk about how we graph each of these. When we're graphing inequalities, less than and greater than have an open dot. So let's make a third row here for graphing. These two have an open dot and these two have a closed dot. Because these two actually have the equal sign, so that tells us that it could actually equal whatever number it's on. These do not equal whatever number it's on. It's either less than that number or more than that number, so we can't put a dot on the actual number. Okay, so we're gonna write an inequality for the statement and then sketch the graph of all the numbers that make the inequality true. So the temperature T in North Dakota has never been below negative 36 degrees Fahrenheit. So I'm going to say that temperature has never been below, so it's always been greater than or equal to negative 36. So I find negative 36 on my graph, so negative 30, negative 40, negative 36 is going to be around here. And this is going to be a closed dot because it has actually equaled negative 36, but it's never been colder than that. And the temperature does get higher than that, so we shade the line. Now, my dot is actually on my number line and my shading is just darkening up the actual number line. If you draw yours up here above it, I'm counting it wrong. It is not correct. You're actually putting a point on the line and shading on the line. Let's try another one. The elevation E in Wisconsin is at most 1,951.5 feet above sea level. So the elevation E is at most, so it doesn't get above, so it'd be less than or equal to 1,951.5. Now, when we graph this, we find 1,951.5, which would be way up here. And it's a closed dot because it does equal that. And then we shade our line because it can go below that, but it can't go above that. Okay, turn your paper over. Write an inequality for the graph, then in words, describe all of the values of x that make the inequality true. So now we're going to take a graph and be able to tell what the inequality is. So on graph A, we can just call each of these x. And is x greater than 1 or less than 1? Well, 4 is greater than 1, so it'd be greater than. And we know that it's 1, but is it equal to 1? So we look, we have a closed dot, so if the dot's closed, that means it could equal 1. On letter B, we again, I'm just going to choose x for my variable. We have greater than 1. This time we have an open dot, so it has to stay just greater than rather than greater than or equal to. Okay, a solution set of an inequality. A solution set of an inequality is a value that makes the inequality true. Or a solution of an inequality is any value that makes the inequality true. And a solution set is all solutions of an inequality. Okay, so I created a table that says that it gives us some values of x and it gives us an inequality, and then it asks, is the inequality true? So if I fill in -6 for x, -6 plus 5 is greater than or equal to -2. -6 plus 5 is -1. Is -1 greater than or equal to -2? And the answer is yes. I'll try the next one. I fill in -7. -7 plus 5 is greater than or equal to -2. -7 plus 5 is -2. -2 is actually equal to -2, so that makes this inequality true. And then -8 plus 5 is greater than or equal to -2. When I work it out, I get -3 is greater than or equal to -2, which is not true. So to tell if an inequality is true, all we do is fill in whatever value they give us and see if it works or not. So let's take a look at your practice problems. Write the word sentence as an inequality. You have 2 of those. So for example, I'll do number 2 or start number 2 for you. A number n divided by -2 is no less than, so it's greater than, is no less than, and then you have to ask yourself, does that mean that it could be equal to if it says no less than? And that does mean it could be equal to 1/2. So you need to do the same thing for number 1. On 3 and 4, you're telling if it's a solution of the inequality. So you fill in 10 for Q. 10 plus 7 is 17 is greater than or equal to 8. So yes, that's true. So yes, it's a solution. And then on the back page, we have 2 more. Check to see if it's a solution. 2 graphs, just P is less than or equal to 4.5, Z is greater than negative 8.3. You need to label your number line however you see fit. And then on number 9, for your birthday, you want to invite some friends to join you at the movies. Movie tickets cost $8. You can spend no more than $35. Write an inequality to represent this situation. So you don't know how many friends you're inviting, but you know each of them are going to cost $8. So I would say 8F. And then you have $35, which you could spend exactly $35 or less than that. So the greatest number of people you could invite is all the answer you have left to find. How many people could you invite? Could you invite 10 people? Could you invite 2 people? How many people could you invite if you know that movie tickets are $8 and you have only $35? Okay, make sure your homework is done for tomorrow and have a great night.